Hey guys, how's it going? Jacob here. In today's episode, I'm going to go over some of the basics of electronics that you're going to use in several of your engineering classes. I'm going to talk about voltage, current, resistance, series, parallel, all that jargon that you don't understand now, but you're going to understand soon. So without further ado, let's go ahead and get started. So, as you can see here, these are the basic things you're going to need to know when it comes to electronics. You have voltage, whose symbol is V, that's measured in volts, which the unit for that is V. You have current, whose symbol is I, measured in amperes, or amps for short, and that unit is A for, when you're writing it out and such, in case you didn't pick up on that. Then you have resistance, whose symbol is R, and that's measured in ohms, and the unit symbol for that is omega. Here is the basic formula of what is known as Ohm's Law, which is voltage equals current times resistance, or for short, V equals IR. Or if you want to mix things up, you have resistance equals voltage over current, or current equals voltage over resistance, because you're going to have several problems where it gets mixed up like that, so it's good to be able to pay attention to how to do it. If you took algebra, then you should be able to understand it. And here you have how you would sum up the total resistances in a series circuit. So say you have three resistors. You have R1, R2, and R3. The total resistance is the sum of all of those three together, thus giving you the total resistance. Here are some of the series circuit calculations that you're going to need to use. So say you already know the voltage and you've summed up all of the resistances. Now you can find the current running throughout the entire circuit, because in a series circuit the current is constant. So you have voltage over resistance total equals current. And then to find a single resistance, what you can do is take the voltage at a certain point, and then you can have... Okay, my bad, I messed up there. I couldn't remember what I was thinking earlier. If you want to find the individual voltage at a specific resistor, because each resistor has a different voltage, you can find the current that you just found, multiply it by that specific resistance, and that's when you get that specific voltage. So the resistance for the first resistor times the current equals the voltage at that specific resistor, and so on and so forth. Sorry, I kind of stumbled there. I'm only human. And the sum of resistance in parallel, that's where it gets a bit more tricky, because that comes in with a lot of inverses. So parallel circuits are when you have multiple branches for how the current can flow, and you have the inverse of the first resistance plus the inverse of the second resistance plus the inverse of the third resistance equals the inverse of the total resistance. I know that seems a bit odd, but say you have 4 ohms for each resistor, so that's R1 equals 4, R2 equals 4, R3 equals 4. So according to this formula on my screen and on your screens, that would be 1/4 plus 1/4 plus 1/4 equaling 3/4. So that equals 1/3/4, meaning the total resistance is 4/3. Yeah, that's some interesting stuff right there. So I hope you paid attention. Here are some of the parallel circuit calculations. Unlike a series circuit, voltage is constant across the entire circuit. So the total voltage equals the voltage at the first resistor equals the voltage at the second resistor equals the voltage at the third resistor. Voltage is constant in the entire circuit. Now, when it comes to the current, that's when you can just add it up easily. So the total current equals the current at one resistor, the current at the second resistor, the current at the third resistor. Just sum up all the currents at each individual point. That's where you get your total. And if you want to find individual current, what you can do is you can take the voltage that you know, assuming that you know voltage, you might not always, but you take the voltage and you divide that by the resistance at one resistor. So say you have 9 volts and you have at one resistor 3 ohms. That would mean that the current at that specific resistor would be 3 amps. I'm pretty sure I did that right. Make sure to correct me if I'm wrong, but I'm pretty sure I'm right. And the same would go for the second resistor. You just follow that same process. If you know the voltage and you know the resistance, you can find the current at that specific resistor. Once you know all the individual currents, just add all those suckers up and then you can find your total current, and then you'll be just having all kinds of fun. And that's really all there is for that. That's really the basics. So, I hope that this video was informative. That's really all I have to say. Really appreciate you checking out the video. Make sure to like the video. Make sure to comment if you have something that you want to say. Make sure to share the video so other people can learn just as much as you did, because you learned a lot. This was pretty informative. And make sure to subscribe so you can check out more of my videos, so you can learn other things besides electronics, because that's not all there is to engineering. There's a whole smorgasbord of things that you can learn. So again, thanks for checking out the video. See you next time. Bye.